x minus 1 would equal negative sine squared x. So then you'd have to multiply them together, which is stated right here, but you can't multiply them if you don't have fractions because they aren't the same. There's really nothing you can do. So you'd have to change it to fraction for secant squared x, which would be 1 over cosine squared x. Just using your trig identities, you know that secant squared x equals 1 over cosine squared x times negative sine squared x, because negative sine squared x is its own trigonometric identity because there's not another fraction that basically equals it. If just like that. So then you'd multiply that, and obviously 1 and 1 cancel each other out because they're 1. So it would just be negative sine 2x and cosine squared x, which would equal negative tan squared x. The reason why it would equal negative tan squared x would be because, first of all, it's right there. So if you get a different answer, you're wrong, because the equals of here needs to equal this, and that equals this. So negative tan squared x equals negative tan squared x, which means you got this problem right. But the thing that you need to look for is how you do it and what steps you do. So I used my Pythagorean identity, my multiplication, and my trig identities right here and right there, actually. So let me just do. And the reason why it would be negative is because in division, if you negative a positive, this is a negative and this is positive, it's always a negative. And since everything has a square and these don't cancel out at all, then that is also a square. And since you're using your trig identities, this would equal negative tan squared x. So in conclusion, this is how you verify trig identities, and yeah.